All right, y'all ready? Hey, when y'all get certified, y'all got to do this to your Christmas tree. You're at 6. This is what a unit did in Hawaii that we trained. That's right. What's up, man? What? We're not getting into Eve right now. Yeah. Just one sec. I haven't put the IPs up, the new ones. All right, let's do some review. OSPF review. We're gonna do some. We're gonna recap the whole week right now, actually. So, okay. What is the default network type for OSPF? Broadcast. I'll put default network type is broadcast. All right. What is the default OSPF priority? 1. And what is the range? So is lower or higher better? Lower is better? Higher is better. The higher the priority number, the better. Higher priority is better. All right. Can y'all answer this for me? What are the 4 things that need to match in the OSPF hello packet? All right. Hello/hold time. MTU, and what else? That's right. Okay. Now, if I asked you guys, hey, I want to make an OSPF network with no DR and no BDR, what network type is that? Point to point. Network type with no DR or BDR is point to point. Trying to think. Okay. What is the default metric for OSPF? I guess what I mean by that is, what is the algorithm? How do we get our metric for OSPF? Bandwidth, right? It's bandwidth. That's right. Reference bandwidth divided by the actual bandwidth. All right, trying to think if we need to go over anything else at OSPF. Okay, if we're configuring OSPF, which command is right? Is it going to be the top or bottom? Good job. Yeah, the bottom. Why? So yeah. You use the wildcard mask, right? Yeah, I got you. It's like pretty much the inverse of. It's the inverse, right, of the subnet mask. If I want to look at my OSPF neighbors, what's the command? Show IP OSPF neighbors. Yeah, a lot of times, like for EIGRP, BGP, there's all the same command, but people always forget the IP in front of it, and won't get you the right command if you miss that. Dude, sometimes classes do not listen. Okay. So I'm just trying to think what else would be on the exam. All right, that should be it for OSPF. Okay, cool. Let's go over some static routing. What kind of static route do you guys think this is? Now remember, we have 4 types: floating, default, a host route, and then just a regular static route. What kind of static route is that? Host route. Why is it a host route? Yeah, you're right, the subnet mask. Okay, that's a /32, which means we just want to route traffic to an individual host. Okay, so that's a host route. Okay, now tell me what kind is this? We have that extra number at the end there. Floating. It's a backup. And what's that number doing? Yep. It sets the AD higher, right? All right, and then last one we'll go over. When we have all zeros, what kind of route is that? Default route. And that's a catch-all. So like if you have this in your routing table, there will always be a place for destination IPs to go. Now the reason I say that, because I'm about to go to that other diagram where you're reading the routing table again and see if you guys remember it from Wednesday. But sometimes the answers on the exam will be like discard packet, which could be an answer, right? Sometimes the router won't have a destination and it'll discard the IP packet. But if there's a default route, it'll never do that, right? Because there's always going to be that default route to send destination IPs. All right, let me find that diagram. Where was I fucking around with that thing at? So this is why I'm gonna organize this over the weekend. Here we go, and put it into sections. All right, y'all remember this? Okay, we're gonna see because you'll have to pass. Okay, let me clean this up just a little bit. So it's all OSPF. So what is R1 going to do with this destination IP? Is it going to go out R2, R3, or R4? What do y'all think? Who raise your hand if you think it's R2? All right, that's pretty good. No one should think it's that. Raise your hand if you think it's R3. All right, it's R3. Because the range is what? Can anyone tell me what the range is for this? Yeah, plus 63, so 191. Okay, that falls within it. Hey, you got hurt on a jump? Yeah. You got that shit like in your record? Yeah. Okay. I was thinking about it the other day. I was like, hope that kid went to the doctor. Okay, now what are we gonna do? Which path is R1 gonna choose? R2, R3, or R4? R3 again. Why R3 this time? Administrative distance, right? Because the prefix length is all the same now. So now we're going off the AD, the administrative distance. Well, because this is EIGRP, this is RIP, this is OSPF. So we look at our chart, right? EIGRP is the lowest administrative distance, which is better. I know it gets tricky because like OSPF priority, higher is better. And then in a lot of technologies, lower is better. So you're just going to have to get used to that. Yeah. Yeah. That could have been a static route. Yeah. Okay. Now let me make sure you guys have memorized the administrative distances. Okay, what's the administrative distance for external EIGRP? What about for RIP? ISIS? Static? OSPF? 110? And then EIGRP? 90. There's, if we had a local or connected route, just to let you guys know, it would be 0. That pretty much means the network like is directly attached to the router, okay? All right. Some routing. Trying to think. I'm trying to like go through what would be on the exam type shit. Okay. All right. Let's say we're using the dynamic trunking protocol to configure a trunk. And switch 1 is configured as auto. What does switch 2 need to be configured as? Desirable. Yeah. I understood what you were saying. Dynamic, desirable. Okay. If I wanted to disable spanning tree protocol on this interface, connected to PCA, what's the command? Nope. Someone said it. I think I heard it. It's not no. 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 Port fast. Someone said it. Spanning tree. You need to know that. This disables spanning tree on interfaces. I told you to write this down. I don't know if you guys remember. What else does this, port. I don't know why it autocorrects. I'll fix it. But it's port fast, not port fast. What else does this command do?
Generate topology change notifications.
Yeah, say it louder.
So spanning tree port fast doesn't generate topology change notifications.
That's right. So there may be a question that's like, what's a benefit, or when you use this command, and the answers you're gonna be like, what the fuck? Like that's we were told to disable spanning tree, but the answer will be it does not generate topology change notifications. Okay, let's say VLAN 10 is in this network. And we have to choose the root bridge. If I told you both these switches were left at the default spinning tree priority, what would their priority number be for VLAN 10? The default spanning tree priority. Yeah, but it's for VLAN 10, so what is it? 78. You just add 10, yeah. If I did VLAN 400, it'd be add 400. So the default spanning tree priority is 32768 plus the VLAN extension ID, the VLAN number. Okay. So now, since their priorities are the same, what's the tiebreaker to determine who will be the root bridge? Lowest MAC address. Let's go through this. So switch 2's MAC address is going to be this right here, Charlie Bravo, 49, Alpha 9. Switch 1's MAC address, I'll just put it over here. This is switch 1's MAC address. I'm just putting it over here. Okay. So I'm just going to teach you guys how to do this one more time because some people had some questions. When we line these two MAC addresses up, what do we need to do to figure out which is going to be the lowest? Okay. Someone, yeah. So convert from hexadecimal to what? Dewey Decimal? Yeah. Yeah. You're on the right track. It's fine you don't remember the vocab. You convert it to dotted decimal, okay? So that's just regular numbers, 0 through 15. So let's do that. Okay. So this is 0. This is 1. That's not 10, right? Someone said that the other day. This is 2 plus 3, which is 5. Okay, what is Charlie? What number is that? 12. If you remember that A is 10 and you work your way up from there, that's how I still do it to this day when I teach you guys. So 12 plus 11, 4 plus 9, then 10 plus 9. Okay, and then let's add all those up. 6 plus 23 is 29, plus 13, 39 plus 3, 42, 61. Okay, 0, this is 1, 5. Now what is this? 15 plus 9? 14 plus 9. 23. Okay, y'all see what I did here? You see how the first 8 hexadecimal digits are the same? On the exam, they do that a lot, okay? So you can sometimes, just by looking at this, if you were to look, you got used to doing this conversion, you would notice, oh, these are like, it's equal until the last 4, you know? So you don't maybe have to do a full conversion, you just got to do the last 4. A lot of the questions, you'll notice that. And then E, what the fuck is that? 14, 19. So this is, okay. So which is lower, switch 1 or switch 2? So switch 2 is going to become our what? Root bridge. He's the king. Or a queen, too. All right. So, switch 2's port right here. What's its port role going to be? Port role. I'll show you. The root bridge port roles are always in a designated role. Always. Always. And what kind of state is it going to be in? Forwarding. Always. For the root bridge, okay? For switch 1, what kind of role is it going to be? No. No. Root port. It's a root port because it's facing the root bridge. So all the non-root switches, remember, after we decide who the root bridge is, we have to converge the network. So all the non-root switches have to determine how they're going to forward to the root bridge. So once they elect that port becomes the root port. And it's forwarding. All right. We're going to go over Ether channel now. All right. LACP. I'm going to ask you guys a few questions. Is this Cisco proprietary or multi-vendor? Multi-vendor. It's the IEEE standard, okay? If I make this port channel group 15 and this port channel group 10, will it come up? No. Why? That's right. It has to match exactly. Every single configuration has to match exactly on these Ether channels. If I told you I want distro switch 1 to actively send negotiations, what kind of LACP mode would you choose? Active. And if I told you distro switch 2 wants to just wait for the negotiations, what mode is that? Passive. If you can memorize what I just said to you aloud, you'll be pretty good for the Ether channel questions, okay, on the exam. And then PAG-P, that's Cisco proprietary. Just memorize that, okay? All right. If I wanted to do neighbor discovery on these devices, and one is a Cisco device, and one is a Dell switch, what am I configuring? LLDP. If I want to do neighbor discovery in a multi-vendor environment, I configure LLDP for neighbor discovery. Okay. Now let's say we configure CDP on this switch, okay? We're connected to another Cisco switch over here. How would I enable CDP globally on that switch? That's right. So top or bottom, which one is the correct way to do it? The top. Because you have to be in global configuration mode, okay? The modes matter. This is what's going to trip you up on the exam. If I wanted to change the timer, the hello timers, which way is correct? The top again, okay? Just to reinforce that. And then LLDP is the exact same commands when it comes to globally. If I want to enable LLDP at the interface level, how do I do it? Transmit and receive, right? So here, which one is correct, the top or bottom? Bottom. It's important, right? You got to be able to recognize that. And when you're like on an exam environment, you only got 2 hours for 90 questions, and you're like, oh yeah, I remember LLD transmit, and this is A and this is B. Just remember to take your time, okay? Like with Cisco, you can't flag questions either. You can't go back. So like if you answer a question, hit next, you cannot go back and change your answer either.
Oh, if I leave it blank, can I come back?
No, you can't. You can't even. If you leave it blank and hit next, it won't let you.
Okay.
It'll say like answer the question.
This motherfucker time? Is it a time test?
Yeah, 2 hours.
You only got 2 hours? Well, guys, it's
Yeah, man. Cisco's legit because you actually gain skills from this. So, not to disparage CompTIA, but you know, CompTIA is easy. Don't be forgetting then. Okay, I think we're pretty good. Control plane. Oh, okay, I'm gonna ask you guys some IPv6 shit, because you probably forgot it. All right, guys, look up here. Out of these 4 options, which one is a link local IPv6 address? D. Delta. Okay? Because FE80, that first hextet, that's link local. All right, same options. Which one is a multicast? B. Okay? B. Now, this would be 2 right answers, but which ones are global unicast? A and C, right? Now, if I asked you which one used this format to generate the address, which one would you choose? Charlie, why? That's right, that FFE. See? You memorize? Okay. That's actually pretty good. If y'all, what you just did right now, if you can memorize that, be pretty good. Okay? Be pretty good to go for IPv6. One last thing. Sorry, this just takes a while. It's IPv6. Okay, that's 5. That's 6. I'm going to move this somewhere else. There. Okay, if I wanted to shorten up this IPv6 address, we're going to go per hex tag. Yep, this is still 2000. And then Delta Bravo 8. Which one would this be? Yeah. And then just a 1. All right, good job. Yeah, yeah. Though this shit will be on here though. They always ask IPv6, always. Yeah, I gotta cut out a lot of my live stream now. Whatever. How many double colons can you have in one IPv6 address? Just 1. Okay, cool. You know, this is the first class I've ever like reviewed like this. Hopefully it works out. Well, no, we have 10 days, that's why, so we actually have time. I've never taught a 10-day CCNA, so. Okay. We've been talking a while. Let's go ahead and take a 10-minute break. I'm going to upload your event GIPs, and we're going to go over HSRP. No. Don't sound. Yeah.
Fuck her then. Fuck her. Yeah, let's see what's going on.
No, I don't.
Then you would be in that bitch.
Like the Joker out there. Because it's Joker was fine for us. We get matching yellow jumpsuits. We all go in red. I do red. We get the matching jumpsuit.
Hell no. Girl, shut the fuck up. No, man. Still, how many questions on the TV? Somebody tell me.
Like 75.
If everybody had a different amount.
On Sec Plus,
For the CCNA, how many questions?
there's like 89, 90.
Okay.
Yeah.
200 shit, we always gonna go to the kitchen. I was just gonna click through that motherfucker at this point. Like, I'm taking ACT.
Oh, no, I was thinking of the high school.
All I need to say, I need a degree. Oh God. I was just gonna be like, I'm just taking the same route. I never see this motherfucker.
I'm mad.
Yeah. Oh yeah, you did. You fucked up me back. That's that shit right there. They start rumors. I shouldn't ask you. That was on me. Oh man.
I'll make your ass study every time.
Shit, 200 questions, 2 hours. I don't even think studying gonna do it. Y'all ask some cooking. I mean, you still gotta cook anyway.
Shut up. Oh, God. Stop listening.
That nigga be, that nigga be. Let me tell you. Two questions. You a fix that shit.
Is this one of you guys? Okay. It didn't let you access the whiteboard? You have a Zoom account, right?
That's a good picture. This? How do you even get in there? Now I don't want to press right now.
Try to hit that link again. Let me see what it comes up. Hit that Zoom link again on your phone. Oh, that's old. Here, go to your Signal chat. Yeah, that one. Yeah. Yeah. That's an old one from another class. There you go. Did you find that on the Google Drive? Okay, I gotta get rid of that. Okay.
My Christmas tree on my life. On my Christmas tree, I'm putting ski mask.
No, nobody put no dang on, no, you're not putting no dang on ski mask.
Ski mask for Hellcats. And I bet you like a gaming ornament on that.
You can throw gaming ornaments, but
I
none
think
of that extra stuff.
a ski mask gonna go on top.
No.
On my life.
You can just get, okay, so you tell me you gonna get the goddamn black Christmas tree with the black Nike shoes under the tree?
Black horses one time, not probably on.
Now you give it ideas.
Probably on or something.
Got clip tape from the branch.
He took black.
I'm gonna put a black. Nah, we got drums. we got five, 6 drums. Those little bags ain't gonna cut it.
So you gonna put a new nail on it too?
Pretty much.
Put a goddamn safety vest on the Christmas tree.
Nah, we don't do that.
You gonna go out like this?
It's gonna be a ski mask.
Make them dress up like this.
Black horses. Ain't no star, ain't no nothing going
Put the skinny jeans at the bottom too, right down there. Make them look like a real.
on. You know how they wrap it in that little, whatever that thing is, I'm gonna wrap mine in bandana. I'm gonna wrap my shit in bandana. Christmas tree definitely gonna be different. Ain't nobody never seen no shit like this.
All right, guys, let's go over first hop redundancy protocols. So a first hop redundancy protocols allows us to have redundant default gateways. So I'm going to go through with you the 3 protocols that enable this. HSRP, VRRP, and something called GLBP, which I'm not going to go over GLBP too much because it's not on the exam objectives. So we have a network diagram up here. And real quick, what kind of network architecture would you consider this right here? The distro, core switch, and access switches. Collapsed core. And if this is a collapsed core, what size of business would use a network architecture like this? Small to medium. With what kind of growth? Minimal. That's the key word. Good job. All right. So we have distro switches up here. So we learned Wednesday, I believe, or maybe it was yesterday, I can't remember. But what do we need to configure on these switches to give them IP routing or to give them layer 3 capability? SVIs. So let's do it. So we have VLAN 10 and VLAN 20. So distro switch 1 will have SVI 10.0.0.1. Well, hold on, let me make this a little cleaner. SVI 10, and we got to give it an IP address. And we'll have that for VLAN 20 as well, SVI 20, 10.0.1.1. And then distro switch 2 will do the same thing, 10.0.0.2. Okay, pretty standard. But you guys kind of see where the issue's heading here? So the PCs down here, like PCB, PCA, they're going to have an IP address, 10.0.1.10. They'll have the subnet mask, /24. Then they'll have the default gateway. So we have two multi-layer switches up here. So what's the default gateway going to be? Who can tell me? Could be either, right, technically? Yeah, it could be either. So let's just say we make distro switch 1 our default gateway. Well, what happens when distro switch 1 comes down? Technically, we have distro switch 2 that could take over, but what would we have to go do on PCA? Change the default gateway, right? So we'd have to go in there and manually change the default gateway. So obviously, that's not scalable. It's not feasible. So what first hop redundancy protocols allow us to do is it allows us to take two routing devices, whether that be routers or multi-layer switches, and have them communicate over a shared protocol like hot standby redundancy protocol. And it's going to allow them to share what's called a virtual IP and a virtual MAC address. And one's going to be the primary, one's going to be the redundant or the backup. And if we choose distro switch 1 to be the active and this will be the backup, if this comes down, we automatically fail over to distro switch 2 because we're going to be sharing a virtual IP together. So here's how it'll look. So let's say distro switch 1, distro switch 2. Let me clean this up a little bit. I'm going to get these over here. And I'm going to move these over here. Hold on. Okay, so here's the SVIs we have on both. I'm going to switch up the IP addressing here. This is going to be .3s. So what we're going to do when we configure HSRP, and I'm going to go through the CLI and show you these steps, is we're going to tell distro switch 1 and distro switch 2, you guys are going to be in this HSRP group together. Kind of like an ether channel group. So we're going to say standby group 10, 20, whatever the case may be. And once we activate that on both sides, they're going to start sending hellos to each other. Hello packets. HSRP hello packets. And then they're going to decide, hey, here's the virtual IP we're going to share. And we're going to choose who's going to be the active and which one's going to be the standby. So distro switch 1 and distro switch 2, for each SVI, is going to have a virtual IP. Holy shit, my shit's going off right now. Okay, hold on. And that virtual IP is going to be shared between them, and that's going to be the new default gateway for your users. So at the actual interface level, on both switches, SVI 10, SVI 20, on both switches, here's the command. So we're going to do this on both switches, guys. It's going to be interface VLAN 10. We set the IP address. So this is distro switch 1, so our IP address is 10.0.0.3 with the subnet mask. And then here's our commands to configure HSRP. It's going to be standby, the group number, and then it's going to be IP, and then the virtual IP address. And that's it. That's how we get started on HSRP. Let me clean this up. So you do this on both sides. And you do it for every single SVI that you're going to have. They still need their own unique IP addresses, right? But then this is what they're going to share, the virtual IP. Okay, any questions on that? That's, to me, pretty simple. So to be able to have these two devices share a virtual IP, which becomes a default gateway, and one's going to be active, one's going to be standby, which just means primary and backup. So now, how do we decide who's going to be the active, who's going to be the standby? Y'all ready to memorize some more numbers? All right. So it's going to be an HSRP priority, okay? Higher priority is better, but the default is 100. And the range is 0 to 255. So let's write this stuff out. Remember, this is in your slides as well. All right. I'll come down here. So HSRP, the active is chosen by higher HSRP priority. Default is 100. The range is 0 to 2. It's actually like 1 to 255. And when we activate this, so when I typed in this command, standby 10 IP on both of these, that immediately starts sending hello packets between each other, okay? Just like routing protocols. And in that hello packet is going to be the priority, just like in OSPF, right? When we choose like DR and BDR, it's very similar. So in our little diagram here, if I want distro switch 1 to be the active router, this is a command. You have to memorize this. It'll be standby 10 priority 110. Or just has to be higher than the default, right? And the default is 100 in this case. It's not 1. Sorry for my funnel. I got guys testing down at Range Regiment right now, so they're like hitting me up. Okay, another thing we're going to have to know about is called the preempt command. So this is what we've configured so far. So for VLAN 10, distro switch 1 is going to be our active router, okay? But when this comes down, so when distro switch 1 comes down, distro switch 2 is going to take over, okay? And it's going to be that standby, because it's going to be a standby router. Now it's going to turn into active. Well, when this comes back up, and this could be, if the interface went down, whatever the case may be, it comes back up, guess what? It's not going to take over again as the active. So if we want it to, though, so in the case of distro switch 1 coming offline, distro switch 2 takes over as the active router now. When distro switch 1 comes back online, by default, switch 2 is going to stay the active. It won't just release it back. If we want it to, if we always want the active to be active, even in the case of failure, you have to type in this command right here. It's called standby preempt. So this ensures that the active will always be the active, even in the case of failure, okay? Something else we have to know about. There are 2 HSRP versions, okay? So we have HSRP version 1, and we have HSRP version 2. Do y'all see this number right here, standby 10? That's the group number that has to match, just like Ether channel. With version 1, the group range is 0 to 255. 255. With version 2, The group range is 0 to 4096. We're almost done, don't worry. Another additional note you're going to have to take. HSRP, neighbors, what do you want to call them, routers participating in HSRP, they share a virtual IP. But what do we know about sending traffic to our default gateway? When we build that packet, we have a layer 2 header and a layer 3 header, right? That layer 2 header, the destination MAC, is the default gateway's MAC address. But if they're sharing the default gateway, what else do they need? A virtual MAC address as well. You'll have to know the default virtual MAC addresses. Let me pull them up. I don't memorize them, to be honest. So version 1 and version 2 have different default MAC addresses. Y'all ready? So version 1 is going to be 000.0charlie07.alpha charlie00 through alpha charlie FF. So y'all see these last two digits here? I'm going to put them in red because these two digits are determined by the group number, okay? So if we have standby group number 10 and we convert that to hexadecimal, that would be 0 alpha. So the shared MAC address between these two on version 1 would be 000.0charlie07.alpha charlie0 alpha. I'm going to write that out, don't worry. Version 2 is going to be this, 0 charlie 9 fox dot f 000 through FFF. So remember, to get these variables, you take the group number and convert it to hexadecimal. See how hexadecimal conversion keeps coming into play with a lot of different things? So for standby group 20, let's convert the number 20 to hexadecimal. What is that going to be? Can anyone take a wild guess? That's a good guess. But hexadecimal goes from 0 to 15, right? So how I would do this quickly is 20 minus 15, right? Because that's the highest a hexadecimal digit can go, to 15. So that would be F, right? Then what's remainder? 20 minus 15 equals what? So it would be 5F. Make sense? Yeah. The correct way to do it is to like literally convert this to binary and then take that binary and split them into 4, but anyways. So this MAC address would be 000.0charlie9f.f0 5F. What the fuck? Hold on. There we go. All right, any questions on that? Yeah?
Why does the 5 have to come before the F? How do you remember that?
It's just right to left when you look at the binary. Yeah. So like, if we actually converted this number to binary, we'd have our chart. So this is hexadecimal digits. So it'd be 8, 4, 2, 1, 8, 4, 2, 1. And we'd start right to left, actually. It's weird the way it works, but. So 20 minus 8, this is all ones, right? 1, 1, 1, 1, and then remainder would be 5. Then we bring that over. 0, 1, 0, and then 1. And then we convert that, right? So this hexadecimal digit would be 5, and then this would be F. Make sense? Yeah. Yeah, the hexadecimal conversion always comes into play, huh, guys? Okay. Everyone take a breath. So that's HSRP. We have to learn about another one called VRRP. And here's what you need to know about it. HSRP is Cisco proprietary. I don't know. The vocabulary here is that we have an active and a standby, which just means like primary and backup, but that's just the HSRP vernacular. VRRP is the IEEE standard, which means it's what? Multi-vendor. Oh, fuck, what do they call there? I think it's master and something else on. Master and backup. You looking at the slides? Okay. Yeah. So they call it master and backup. And it also has its own unique MAC address, but you don't need to know it for the exam, so we're not going to go over it. On the exam objectives, it literally says you need to know HSRP, okay? So that's what we're going to know. Now, for the rest of the week, I'm going to go exactly by the CCNA exam objectives. So the only other thing we actually configure is ACLs. So we're really not going to have, I'm going to give you guys labs to do, but they're just kind of going to be because I want you to get hands-on experience. For the exam, you don't need to know how to configure this. You don't need to know how to configure all the other technology we're going to learn, like DHCP snooping. You don't need to know how to configure DHCP. You're just going to have to explain the technology if you actually look at the CCNA exam objectives. So we're going to take a break. We'll come back at 10:48, and then I'll configure this for you on the board. Then we'll go to lunch, okay? You won't actually have to do this lab. There is one built. I have one built. You can if you want, but you don't actually have to per the exam. So let's come back at 10:48.
Read the right answer, they clicked the wrong one.
Fuck, what was I just about to do? There we go. Do, 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 do. Yeah, what's up, man?
Have you ever had like issues with building fault tolerance on like a bigger network where you'll have like two different forms of transport, they all converge into one, and you're trying to do like fault tolerance. You got so much stuff in the back end that's pointing to different things. Is there a solution to that?
Well, yeah, but that's like more advanced routing if you're talking like the transport side. Like campus side, like downstream the LAN fault tolerance for this is easy. Like I don't ever had any issues configuring it. But on the routing, if you have two forms of transport going to the same destination, so let's just say a domain controller, like so, you have people going to a domain controller at your step site, whatever it is, and you have FDMA and TDMA. You have to make sure that you're building into those GRE tunnels that are going out there the load balancing correctly, or the primary and default, like primary backup correctly. So like in JCU, yeah, we built that out. We had like four forms of transport up at a single time. And sometimes we'd get what's called asynchronous routing issues, where you're going out one path and coming back in the other path. So you'd go out your primary FDMA, then it would route you back through TDMA. And for that, you have to work between spoke and hub to get your metrics right.
So it's not a quick fix.
No, no.
I was like, at one point I had
Between spoke and hub, it's a whole thing,
the whole thing.
Yeah.
They
And that's if you want it automatic. Now, if you just have a tunnel up and it goes down and you bring up your other tunnel and you have like 30-second failover times, that's a solution. But if you want instantaneous, like this tunnel's down, you automatically route out the other way, that's more configuration. That's between you and the hub, so. Yeah. A network architect would do it, not you on your own spoke, Just because it's that, between spoke and hub, so.
I mean, like I said, I had two different versions of it. By myself, I figured it out from scratch, and I thought like maybe if I put like a switch in there, that show.
Well, so you can do it on your own, and you'll have fault tolerance. It just won't be architectured out correctly to have instantaneous, and you could have asynchronous routing, right? So if you put up TDMA and FDMA, and they're both routing at the same time, you could fall into asynchronous routing, which isn't like you're going to be up. You know what I mean? It'll work, but it won't be like perfect architecture, if that makes sense.
Yeah, especially if like, because at one point I was like, I think it was my TDMA that wasn't as fast.
Yeah.
So just the speeds alone, you could tell when it was on.
Yeah. So like when I was in Whitesoft, right, they didn't have that they didn't have two tunnels up at the same time, but I would plug in TDMA and ISP, and I would just manually make it work, which you can still do, but it just won't be simultaneous backups. Does that make sense? Yeah.
I said, I think like my biggest thing, I had to then take TDMA link and then run that through ISP at the same time, and like it did that thing that you was talking about. I think maybe the preamp might have been the problem, but they had like SLA magic tracking, whatever that is.
SLA track, yeah. Track object using SLA. Yeah.
Like they try to have me like, because I wanted to read something like you gotta use this, and I tried to do it, and every time I got the tone of the fault tolerate over, or whenever I tried to bring the other one up, it wouldn't regular. Like even though I said keys to it, it wouldn't.
It wouldn't come up. Yeah. So track objects and SLA sometimes don't work nice with DMVPN configurations too. So it's just a little, yeah, it's more than just, yeah.
That's in CCNP though, right?
Yes. Like the technologies, you'll learn it, but specific network architecture design, you know what I mean? Like, yeah. CCNP then, yeah. Are any of you guys watching our live stream? Okay, I got 10 watching right now. Let's go. Now it's 9, fucker. About to make it 8.
You can learn, but sometimes you might not see the updates on his computer or whatever. I'm not sure which one you did.
All right, let's go ahead and configure this so we can go to lunch. All right, let's look at our diagram. So this is pretty simple lab. We have R1, R2. We're going to ensure that R1s are active. We have the actual IP addresses on the physical interfaces. We always need that. We still need the physical interfaces, or if it's an SVI, to have an IP address. The switch is just like a dummy switch. It's not, we don't need trunks or VLANs, right? Because we got no VLANs in here. And then we got these PCs. So the default gateway for the PC is going to be .1, this virtual IP. So what I'm going to do on R1 is make sure that it's the active. I'm going to make sure that it always stays the active, even in the event of failure. So let's go through and do it. And I'm going to configure HSRP version 2 as well. So I'm going to go into interface gig 00. Let me make sure that its configuration is good. It's shut down right now, so I'm going to make sure to no shut that. And then I'm going to do our command. So I'm going to type in standby version 2 because I want to use HSRP version 2. Then I'm going to type in standby 10. See, that's the group number. We have 0 through 4095. So that was an error. I said 4096. It's 4095. Then I'm going to give it its IP address. What is it? 1.1. Okay. So you don't need a subnet mask after when you're assigning the virtual IP. Okay, guys? It's just the IP address. That's the full command. So right now we're good. We could stop right here and it would come up with R2 once we configure it. But we want to make sure that this is our active. So we're going to set the priority higher than the default. The default's 100. So we just have to set it 101. That'll work. And then I'm going to type in this preempt command to make sure that even in the event of failure, R1 comes back up. Now let's go over to R2. R2, let me just make sure everything is configured on here. Do show IP interface brief. We have our IP address set, but we're going to go in and no shut it. We see it's down right now. We're going to do standby version 2. And then we're going to set the virtual IP. And remember, the group numbers have to match. So standby 10 IP, then the same virtual IP. And that's it. We don't need to do the priority or the preempt command because that's not going to be our active. R1 is going to be our active. Now let's do some show commands. Let me actually do a quick ping. Let me make sure we can talk to each other. There we go. So the only show command you'll have to know, and this is more real world, because any LAN you go on that's bigger than a small office of 5 users is going to have something like this. I've been on so many different networks. Even on a Navy ship, it had this. It had this configured. It was VRRP, but VRRP and HSRP, like the configurations are almost the exact same, except instead of standby, you just put VRRP in there instead, okay? So if you can know how to configure this, you can work your way through both. So the show command we want to know is show standby brief, and check it out. From R2, we see that we're the standby, and then our active is located at this physical IP address. That's R1. Then standby is local, and this is our virtual IP. We do that from R1, show standby brief. We see that or right here, we're the active, and the standby is at this physical IP. Now let's do some ping tests. So we're pinging. Let's see how automatic this failover is. Come on. So let's go into R1. And let's go ahead and shut down interface gig 00. So what should happen here? R2 should take over. So our ping, we might get a few errors, but if this is working correctly, it should fail over to R2. Y'all see that? So yeah, we had, we missed one ping. Okay. Show standby brief. Now we say shit's unknown because we're down, right? We go over to R2. Now we're the active. Y'all see that? R2 took over as the active. Now, since I configured preempt, what should happen is when I bring this back online, it should take over. Okay, do we see any hiccups here? Let's see if this takes over. HSRP has a 10-second timer, so it could take up to 10 seconds for it to reconverge with its neighbor. All right. See that 12-second one? I bet that's when it happened. Okay. Standby our HSRP came back up. Okay. See, we're back up now. All right, this is actually interesting. This actually is good. I like this. This is a good thing to show. So even though we had preempt enabled, and even though our priority is higher than R2, Look, it never switched back over. Do y'all see that? So the book says that the preempt command will make it, but as we can see here in the real world, what happened? It didn't work, right? So this is a good thing to show you guys. That sometimes what the book says in real world, sometimes don't always happen so nicely, okay? But for your exam, just know that's what they want you to know about preempt, that it should take it back over. But it's fine. What the book says, what happens real world, sometimes just differ, okay? Go ahead.
I don't know if this is a stupid question, but if you were to configure the virtual IP, so
Mhm.
you configure it as a default gateway on any of those devices then?
Yeah, that's not a stupid question. Yeah, the virtual IP is the default gateway. So let me go to this. See, gateway 192.168.1.1, which is actually common. People fuck that up because they're so used to just putting like the actual like interface IP. So they would put like .2 as the gateway for this PC, you know what I mean? And then it wouldn't work, right? Let me show y'all something too. Actually here. Show IP ARP. Actually, I don't know if I'll be able to do this. Show you what I want to show ARP. So let's ping our default gateway from this computer. So y'all see that MAC address? Look at your notes. That's the HSRP MAC address, right? So in our ARP table, when we're doing our layer 3, layer 2 mapping, it recognizes the virtual IP in that virtual MAC address for the default gateway. And y'all see this? So our standby group was what? 10. So there you go. Because that kind of goes to your question, like why is it you go right to left. It's kind of weird, but yeah. So A equals 10. Alrighty. That's perfect timing. Look at that. It's almost 11. Do you guys have any questions on this? Okay. Let's go ahead and go to lunch then. Let's come back at 12 o'clock. And then what did I say I want to go over? Sorry. I have like short-term memory. DHCP, NTP? Yeah, that'll be a good way to finish it up. Let's come back at 12. Yeah, come back at 12. That's good.
Not well, but don't exactly think that would be the best idea.
Just don't be broken it.
Oh yeah, sure.
You could be trying getting better.
So like, for when we're trying to like, I guess evaluate how we're doing, right? Like, is there like test exams or like quick test things? Or how would you suggest we go about like this?
Yeah, my practice exams. The ones on my website, yeah. They're the actual questions. Yeah.
My next question, like, how, I know you definitely covered that. Like, how did you get to the networks that you
Okay, we're back. All right. So NTP, it's UDP port 1, 2, 3, and it's going to have 16 different stratum levels. 16 different stratum levels. So what that means is the accuracy. So if there's 16 levels, that means there's 0 through 15, right? Because we're in computer networking. 0 being the most accurate. Who's a Sierra in here again? Okay. Why is timing important in SATCOM? Yeah, that's right. Atomic timing through GPS, right? Yeah, so that'd be like a stratum level 0, okay? And you need that because why? If you TDMA, FDMA, anyways. All right. China's just going to fuck us up. All right. It's true. You guys are the ones. Like if your GPS gets jammed pretty easily, right? Yeah. That messes up your timing. Then what happens to your SAT shots? And then what happens to your ISR feeds? Then the ground force commander can't do what? All right. It's important. It'll be you guys. Probably contractors too, to be honest. But, okay. Here's what you need to know for the exam, though, when it comes to NTP. Sorry, I'm not trying to choose violence with you guys. Just, it's important. So when it comes to Cisco iOS, I'm going to teach you how to configure a router or switch to be an NTP server and an NTP client. So let's say this is our NTP pool out here on the internet. So that's a server delivering stratum 0, okay, our atomic timing. So let's say this is 1.2.3.4. We have R1 here. And then we have our downstream switches. So this is going to be our NTP server. And then R1 is going to be an NTP client. It's going to get its timing from that server, but it's also going to be an NTP server as well for switch 1 and switch 2 here. So then it's also going to be a server for those switches. Now, when it comes to stratum levels, like let's say this server is a stratum 0. Every hop, it decreases by 1. So this router technically will have a stratum 1. And then these switches are direct connections. So like don't think that this switch is 2 hops away. It's directly connected to R1 because this is over IP, right? So then these switches stratum levels will be stratum level 2. All right. Here's the commands you got to know for the exam. To become an NTP client, from global config, the command is NTP server. This is the client command. I know, a little crazy. How you know that? The book? Yeah. These are really the 2 commands you need to memorize. I'm not going to put that. It's just 0 through 15. Those are the stratum levels, though, okay? So for R1, this is the commands we would need. For switch 1 and switch 2, we would just need that NTP server command, right? And because they're getting their timing from R1. Okay, that's NTP. That's as much as you need to know about it. There is like other stuff we can do. Like we can put authentication, we can encrypt it, things like that, but that's not on the CCNA exam. I'm going to bring up my DHCP lab. One sec.
We can write in these books.
You can. They're yours, yeah. But like I said, so these books, like, you know when you guys do land nav, you know those markers you get for it? That's kind of what the same material this is. So, yeah, what you have would be perfect. I don't know if like a pencil or pen would really would come up good on here. All right, let's go over DHCP. So DHCP is how we dynamically assign IP addressing to all of our users. So throughout this entire course, we've been going to the virtual PCs on EVE-NG and statically setting. DHCP takes care of that for us. I'm sure you guys deal with this all the time. On the Windows client, how can you guys get a new IP address from the Windows client? What do you do on command prompt? Okay, just making sure. When I was a private, a sergeant asked me that, and I didn't know, and he roasted me. But I just want to make sure you guys know. Yeah, IP config space / release renew. So here's how DHCP works. Is that my phone? So it's going to be this acronym called DORA. It's going to be discover, offer, request, and acknowledge. This is going to be from the client, and it's going to be a broadcast message using UDP. I believe it's port 68. Let me double check. Yeah. As the destination, right? Yeah. Damn, you smart, bro.
I know. I've been studying.
And then the offer and acknowledge, those are server messages. It's important we understand this because we're going to learn something called DHCP snooping that's going to protect us from rogue DHCP servers. So we have to know which message in the DHCP process comes from the client and which one comes from the server. And it stands for Dynamic Host Control Protocol. I don't think they ask you about acronyms on the exam. So here's the general flow. So here we have our server. Now in networking, we could have a dedicated server. We could have a Windows server that has DHCP services running on it, and we build our scopes in that Windows application. We could also have DHCP on our router as well, our Cisco IOS. This is our client. So once we plug in to our switch and our NIC is set to DHCP, we're going to send a DHCP discover message. The server is going to respond with a DHCP offer saying, hey, I have this IP addressing to give you. The client's going to request that specific IP addressing. It's going to say, yeah, give me that IP addressing. Then the server is going to acknowledge that and go ahead and assign that IP addressing. Now, in that server, your scopes or your pools have a lot of different options. So we need to tell the client about its IP address, the subnet mask, the default gateway, and what else does the client need to know about? DNS, okay? So we're going to have to configure what DNS. We're also going to have to configure a lease time. So DHCP is dynamic, right? And we have lease times assigned to our clients from the DHCP server. Now let me talk about something else. Does anyone know how your VoIP phones get their configuration? That's a VoIP phone. Call manager. So on the wire, how does that work? Anybody know? Yeah, plug that bitch in, right? I'll show you. So in the DHCP pool, or scope, I call it pool because on Cisco iOS, it's what we call it. If you're on a Windows server, they call it scope, the DHCP scope. In our DHCP pool, we're going to have a few options here, okay? So we're going to have the default gateway, whatever that is. I'm just going to keep it simple. We're going to tell the user about the subnet mask. We're going to tell it about its net ID. We got to tell it about DNS. Make this square bigger. We got to set a lease on it. So we'll do like 7 days. That's just what I've always done. There's no like best practice, at least that I've seen. That's an A, lease. For a phone to get its configuration from a call manager, Cisco Unified Call Manager, it has to do a TFTP session to pull down its profile, its configuration. That is an option 150 address. So let's say our CUMC is 2.2.2.2. So in our DHCP pool, in our scope, we have to configure an option 150 IP address. So when this phone comes up and it sends this discover, it's going to ask for that, right? It's going to say, give me my IP addressing. And if this DHCP pool is for our voice network, we're going to deliver an option 150 address. And the phone's going to plug that in as its TFTP server IP, okay? So have you guys ever had to delete like an ITIL file on your VoIP phones? Okay, anyways, when you go through the settings on a Cisco VoIP phone, you'll see multiple TFTP server IPs in there, okay? Because you typically, CUCM or CUCMs, they have a primary and a secondary, so they'll be clustered. So we'll have like a primary call manager and a secondary call manager. So you'll have multiple TFTP servers in there. Now, you guys have been to the field, right? Okay. So when you bring your kits out to the field and you set up a jock, where do you shoot into? Step site here at Bragg?
No, so it's all like here.
Huh?
Like they,
No, you shoot in some. When you set up your antennas, where is your step site at? RHN. Thank you. Yeah. All right. So when you go to the West Coast, is it still the Bragg RHN? It'll probably be Camp Roberts. Damn, how? There's no way in my fucking military career an officer would know more than me when it comes to my job. No way in hell. No offense, but it's you know, you should be worried about leadership and shit. I should be worried about that when I was enlisted. Okay, moving on. The point I'm trying to make here is that those step sites will have a call manager there. And when you go to another call manager, you may have to get your phones directed towards that call manager. So you may have to change your DHCP pool option 150. You may have to delete that ITIL file, restart it. When it's connecting to that new DHCP pool, it'll get its new call manager configuration, okay? So just think about that. Because probably if you go to like Europe, maybe the step site's in Europe, right? And if you're setting up a huge jock in Poland, You know what I mean? Maybe the configuration's a little different depending regionally where you're at. Launch tool, yeah, launch tool. Have you guys ever reimaged the computer? How do you guys do it? Pixie. So the pre-execution environment, and that pre-execution environment's next to what's on there is called a Windows deployment server. And that Windows deployment server, or sometimes an SCCM service or server, has a default image that it delivers to that PC over the wire on the LAN. So what do we need to accomplish that? A DHCP pool. So when you plug in that PC into the LAN, it requests DHCP, and the BIOS setting is setting it to boot over your NIC or your LAN. What you need in there is option 66 and 67. That's going to point you to the Windows deployment server, and then 67 is going to point you to the actual file path where that image lives in that Windows deployment server. So you guys ever wonder how Pixie actually works? One, it stands for pre-execution environment. Looks like a shitty switch. But yeah, you need those options in there. So let's say we ever have like a near-peer threat, right? And the 82nd Airborne Brigade is downrange, and you guys are working at brigade setting up jocks, thousands of users, hundreds of users. You might have to set that up locally one day. It's possible, you know? Hold on.
So you said 66 is the actual deployment server and 67 is the files?
File path. Yeah, like, it could come in hex too, but like 66 will be like, here's the IP, and then of the Windows deployment server, and then 67 will be like the file path to the iOS in that Windows deployment server, so like C drive, whatever the file path, you know? And this is also done via TFTP. No, none of that's in the exam, but some things, you know, you just got to know for the real world. Okay, last thing we're going to talk about, this is exam related. This DORA acronym. You know that, you'll be pretty well off. The client is sending a broadcast. But the server, I should have changed this, is sending a unicast message. So let's draw something up here. We're going to have 3 VLANs. VLAN 50 for our servers. That'll be 1.1.5.0/24. We got VLAN 40. That'll be our data VLAN. Then our voice VLAN here. So 3 different networks. So how many DHCP pools should we have? Yeah, so 3, but for servers, do you think we'll do DHCP on the servers? No. They're going to be static, right? Yeah. Printers. Printers that you're putting on a print server. Would those be static, you think, or DHCP? Static. Local file share, like a NAS. Static or DHCP? VTC machines. Typically, you want to do static, okay? That should be your TTPs, static. All right. So we have our data user right here, and then our voice user. Let me fix this up. Hold on. So over here is going to be our DHCP server. All right. So a broadcast message. Does a broadcast message leave the LAN? What do y'all think? No. It stays within the LAN, right? So if this is my DHCP server on this subnet, and this is my users, my voice phones on a different subnet, will this server hear their discover messages, their DHCP broadcast messages? No, they won't, because it's broadcast, right? So what you have to do in this kind of scenario, when the DHCP server is not local, you have to configure what's called a DHCP relay. I'm going to get rid of that router because I made this a distro switch. So, all right. So on this distro switch, this is kind of tying everything together. What would we create to enable a default gateway for our data users here? On a switch, what do we need to make this a default gateway for our data users? IP address, but what is that called on a switch? SVI. You need an SVI. So, what the hell? Hold on. So here at this switch, we'd have interface VLAN 30. We'd have that IP address, 1.1.4.1. And then to create a relay, we need an IP helper address. You need to know this command. So it'd be IP helper address and then whatever that DHCP server is. Okay? That's for the default. You have to put that under the default gateway interface. So for our, that's supposed to be a 40. Hold on. So for our voice, we have to do the exact same thing, right? Under interface VLAN 30. Now, if we're at a router, and we're doing router on a stick, that IP helper address goes under the what? The sub interface. Okay? It goes under the sub interface. All right, cool. You need to know that command right there. IP space helper dash address. That's how we do DHCP relay. This is going to be a very niche question, but I think you need to know it. The fuck? Okay, check it out, guys. So, kind of, that's supposed to be a /1. Kind of crazy design I have up here, but you may see this. So R1, this interface is going to be a DHCP client, meaning we want this interface to do DHCP to get an IP address. We want that router interface to send a discover message. So R2 is the DHCP relay. All right. So if you have a question that's like choose two, which is the correct configuration? So R1 is a DHCP client and R2 is the DHCP relay. Here's the answer. At R1, you're going to go into gig 00. and type in IP address DHCP. You can do that in a router, okay? And then R2, you're going to go into interface gig 00. And you're going to put that IP helper address command. Any questions on that? May try to trick you and say like gig 01 is the IP helper address, but it's not. All right?
So no subinterface because there's no layer 2.
Nah, yeah, there's no VLANs and shit. Where the fuck am I at? Hold on. All right, go ahead and take a 10-minute break. When we come back, I'm just going to configure it on a router, and then we'll be done for the day. I want to be you. I wanna be you. Why is this shit not fucking working?
You know, tracking. You right. You right. That's true. But you know how to work on it. You never work on it. Write that shit down. We won't put it in tickets no more. Now we know how to do this shit. I ain't tracking none of that shit. Oh, you is a Bravo, right? Yeah. I ain't gonna lie, like, I really ain't feeling the Bravos. No disrespect to y'all up in here. Our Bravos ruined it for everybody. No offense to it's all offense. It's all offense, honestly. Our Bravos ruined it.
Hey guys, I'm going to be going over this lab, so if you want to follow along with me, it's in section 6. We still got a 10-minute break too, so I'm just getting it ready. Just letting y'all know. Y'all can relax.
I didn't like Crocs either, but like my mom keeps buying me all the Crocs. Some of my girlfriends, so you know. Oh, they do? That's crazy. Hell no. They just easy, you know, just slip them in and then like go into sport mode. You know, you just
These automatically come with the sport mode. You ain't even gotta do shit.
see, but sometimes you don't need sport mode. You just, you know.
So I ain't gonna lie.
Oh my goodness. I know it's why
Crocs definitely for some lame ass motherfuckers.
Right, not too much. Not too much.
Is that a statically assigned one?
Anybody
It has a DHCP exclusion.
I'm with you,
So
Wilson.
that's
Oh,
excluding.
yeah, yeah.
Wilson lost his head.
So no. So like, yeah, I should have said it. So like, let's say you have a data pool for your PCs, but then one of the computers you need static for whatever reason. You got to go to the DHCP pool and exclude that IP address. Yeah. So it does. So you don't get duplicates until the pool knows don't assign that or try to assign it. Yeah, yeah.
It took me a while to like get used to it because at first when I
What? Sorry.
You use that when you
Yeah, yeah. If you're putting a static IP on a device that's part of a DHCP pool, then you got to do that. Yeah.
I don't fuck with it. I told him just get a bigger size. That's what I thought he was doing because I ain't never seen him like that. I only seen like the basic colors like the beige.
Oh, right. It's exclusive.
I've always seen like the basic colors.
You missed the exclusive on God. Definitely don't agree on no Crocs right now. You wear Crocs, you overly hating.
I like my Crocs. I don't know why you hate on Crocs.
I'm overly hating.
Because she said I would. Oh, is that what it is?
No, it's just I never fuck Crocs, bro. I don't see like no
You
reason.
want it means you get the big old size and then you put it's like a category.
Them bitches just ain't like
No,
catch my
that's
interest. He's like a real motherfucker. And I feel like this size for lamb ass shit. But I'm changing it up.
just imagine somebody like wear size 14 and use the Crocs. I was like, yo.
Hell no.
Didn't always see your point. Like a certain shoe size with Crocs, that shit was. It's not it.
I mean, she wears size like 10. You gotta watch. I did my mama's shoe test and put my shoes on. I said, hold your feet up. And I went. You had a lot of, you didn't even have that much space in my shoes. Your shoes don't flop when you don't got your shoes in them.
Oh, my shoes?
Nah, my shoes on your feet. Them bitches don't even flop. My clothes.
Those do look funny. I look like Goofy. Yeah, I saw Goofy wearing it that and
I'm
then
fucking with these bitches. You thought you gonna customize that shit for me. Everybody need to get that. Y'all overrated. Everything we need to know in the book. This book gonna help me take the test.
then study the book, bro. Study the book.
I mean, shit. That's what I got
That's
this
the
month.
same. This the same book she been had.
Not physically see it, but I write it.
Because your lazy butt don't want to log into the computer.
Why can't you log in?
When you get home, do you log into the computer?
I do it off my phone. Nah, gotcha. I've been had the website. I still have the app since it was.
I do too.
No, you gotta re-download it.
No, I do.
Cause I helped you.
I had to re-download the app, but I still
I
have
helped
it.
you.
I've been doing it for like a month. I just had an app on my phone no more.
You wasn't doing it with no damn computer. When I took tutorial, you didn't even know
When I
that log
told
in.
you, I said, look, man, security company got like, we have 7 apps, it was up to like 10 apps up
You
on
didn't even know
there.
your log in.
Yes, I did. I did too. I just told you that because I didn't want to deal with you.
You didn't put it on.
Uh-huh. Because you said, oh, damn, you do know what this is.
That was some other
You
shit.
stole me
Oh, shit. All right, let's do it, guys, so we can be done for the day. So we are going to be configuring a DHCP server on R1 right here. So if we look at our networks here, we got 3 VLANs. So we need 3 DHCP pools. I already set up everything else, the trunks, the VLANs. Hopefully I did it right. And I configured our sub interfaces. So we need to make 3 DHCP pools. Here's how we do it. From global config, we'll type in IP DHCP pool and give it a name. This will be for our sales department. We have to set the network ID. So that's 192.168.10.0. Cool thing about this subconfiguration is you can do the CIDR notation as well. So you can do the slash. We have to set the default gateway. So the command is default router and under DHCP config. We have to set the DNS server as well. So we can set a primary and a secondary DNS server. So the first one's primary, second one is the secondary. We can also set a lease time. So pretty much up to a year. Now, if we need extra options, the command is just option. You can look up all the different DHCP codes if you'd like, but I mean, you just have to use them when you have to use them. So like we talked about with 66, that's going to be for like our pre-execution environment. And then option 67 could also be an IP, but it's going to be this, an ASCII string, okay? So that'll be like the file path. Okay, that was our sales. And then option 150, IP, that's for our call manager, okay? Option 150 is for your call manager IP address. So I just did that for VLAN 10. So this is a DHCP pool for subinterface.10. So I'm going to get into one of my PCs, and let's see if it comes up. So I'm going to type in IP DHCP. You see it did that door request. And boom, there we go. We pulled an IP address. Now from the DHCP server here, which is just our router, here's some show commands. Do IP DHCP pool. That'll show us how many leased addresses we have, the range. We can look at bindings. Do show IP DHCP binding. That'll show us the hardware address that's connected to this. Kind of like the ARP a little bit, right? Just mapping a MAC address to an IP address. And then it also shows us the lease expiration. This can become important sometimes if you're ever managing like a jock, like an 05, 06 level jock, and you just got to be able to see like, okay, do we have any conflicts? Are we running out of space? Is our pool getting exhausted? Things like that, all right, guys? Last thing I'll show you, 2 things, sorry. If you want to exclude, so let's say in our sales pool, we want to put up a NAS, local file share. We want to put up some printers, and we don't have a print VLAN or subnet specifically just for printers. We want to exclude that. So to exclude IP addresses from a pool, if you type this in, this is not .50 and .60. This is .50 through .60. So we'll have 11 excluded IPs there. Okay? Yes, 11. 50, 51, 52, anyways. Yeah. So that'll exclude 50 through .60. Okay, guys? Our IP helper address. Let's say our marketing users, the DHCP server, was not on the subnet. Here's the helper address command. IP helper address, whatever our DHCP server is. And what that does, actually, I don't think I explained it, is it takes that broadcast from the PC. So you see the DORA right here, the discover is a broadcast, this request is a broadcast. It converts it to unicast. So it converts it to a unicast message and sends it to the DHCP server, okay? That's what the IP helper address command does. So technically, it can be used for other things as well. I've used this to deploy Pixie servers downrange that are getting their profiles from a main Pixie server. So anyways, cool. You guys have any questions for me? All right, take your books home with you and start doing the practice exams over the weekend. So next week, we're gonna do like maybe a couple labs next week. It's just gonna be like what I did up here. We're gonna get through shit pretty quick. So by like Wednesday, I'm hoping we're done with all the lessons because the next sections are only 35% of the exam. So we've gotten bulk of the way through the majority of the exam objectives. So I want to start reviewing questions next week, okay, and kind of breaking down how to pick an answer and making sure you understand the technologies in the questions. Sound good? Okay. Enjoy your weekend.